There are millions of objects in space. Every time there's a launch to space or a collision in space, there's going to be extra objects up there. The primary purpose of the space fence system is to detect, track, and catalog these objects. Space debris can include non-operational satellites, as well as anything that was used to get the satellite up there. And then if you think about events from earlier 2009 with the collision of the Iridium and the Cosmos satellite, that added a bunch of space debris to the environment too. The first step of navigating through the space debris involves knowing which objects are of size that could actually harm your system. Debris can be traveling at speeds of upwards of 15,000 miles per hour. So one of the strengths of Space Fence lies in its computing capability. For example, of a satellite breakup, sensors may pick up parts of this, but with the Space Fence system online, as these objects cross, it'll be able to detect and track hundreds of these objects simultaneously, helping for faster reconstruction of what just occurred. The importance of the program really comes to increasing space situational awareness. One way to measure this is through the size of our resident space object catalog. The current catalog consists of upwards of 15 to 20,000 objects. The point of Space Fence would be to increase this 15 to 20,000 tenfold, so now you're looking at a few 100,000 objects in this catalog. The power of this information really comes from turning it into actionable pieces of information. What this means is when you're planning a launch for a new satellite or the shuttle, you can navigate through the space debris. The Space Fence system is comprised of up to 3 sensor sites. The sensor sites would be located geographically dispersed around the Earth. So each sensor site has a wide surveillance fence. So it's looking out, and for example, I'll use lower Earth orbit. You're looking out into lower Earth orbit over this wide surveillance fence. All of a sudden you have an object cross, gets detected, then on that object you start forming high quality tracks, where that involves the radar, scheduling more beams, going out there, tracking the object through the entire field of view. So we have new technology that never existed before. We're detecting, tracking, cataloging these objects, performing catalog maintenance, and keeping the operational commanders aware of everything that's happening in space. Much like early warning systems for weather on Earth, be it a hurricane or tornado warning, we can use this information to protect the assets that are out there and forever improve spaceflight.